Hello, welcome everyone to QRT and the new episode of Spark Optimization Technique. Today we are going to discuss about Catalyst Optimizer, also known as Catalyst Optimization in Spark, how it functions, how it can help us, everything. Before going to the main topic, I am your host Ganesh Ghosh. I have completed my master's in data science, also Apache Spark certified by the mother company of Spark, that is Databricks. Databricks certified data engineer, 9 plus years of experience as a data engineer and AI enthusiast. Snowflake certified professional. I always consider myself as a learner. So let's start today's video. Catalyst optimization. Why we need this? Today we'll understand how Spark get faster without code changes. Plain language explanation with everyday example. Our goal by the end, you can explain Catalyst to a friend, even if you don't know, if you don't have the background of a technical professional. I am expecting after this video, this journey, you will be able to explain your friend what is Catalyst optimization. So let's move on to this video. How this work in Spark? Let's understand that part first. So we basically have learned in my previous videos what is Apache Spark. This is a distributed in-memory processing system which helps us to process lots of data, terabytes of data in small amount of time with proper resources. By distributing data in different systems, and while processing it take the data in memory and process. How it distribute the data? It create the partition. I mean, if you have large chunk of data, it will create small part of it, and every part it will send to different system. Suppose you are a manager, you have 10 employee working under you. Now you have like lots of data. You will divide that data into small pieces and provide that data to work to each of your associates. So like that Spark also work. But why we need catalyst optimization? We write code. I mean, end of the day, we are human being, right? While writing the code, we forget few rules sometime. We are not habituated with rules and techniques. Suppose we are forgetting those. Then catalyst optimization, not only then, catalyst optimization work is basically to analyze your things. I mean, when I'm saying things, your objects, your data, okay, it will analyze everything, your code, okay. Then it will create a logical plan. Suppose it knows what data you have, what columns you have in that data or table, what is that statistic. I mean, uh, statistics. I mean, when I'm saying statistics, I mean, you know the statistics. I don't need to explain. So now you are providing your script. Now it will prepare a logical plan. It will simplify uh, every expression. It will filter out few data and columns which is required to process what you want. It will do all the planning what you need to do to achieve your desired result, what you have written in your code. Okay, it will prepare the logical plan. Then it will prepare the physical plan, you can say. Okay, so suppose something need to be broadcasted. Okay, what type of join it can do in your code, what changes required, how it can plan it better way. Okay, that things it will plan. Suppose let's give you an example. Suppose after logical planning it has prepared, I mean physically planning, it has suppose in your script you have used join, so what kind of join it will do. Suppose it has prepared a plan where it is doing the broadcast join, another plan where it is doing supple merge join, okay, sort merge join, okay, different type of join. Now in the last stage it will do the cost based selection. I mean, it will, suppose it has prepared three or four physical planning, okay, how to execute the code. Now based on the cost and the resource utilization, it will pick the cheapest one, okay, for you, which will use less resource and cost you less, okay, among them. Then it will process that script or plan accordingly, you can say, okay. So yeah, let's move forward. So we call catalyst equals to Spark Smart Planner. So what does mean? So you can think like something you already have, okay, which can plan things for you. I mean, uh, some systems. Suppose you already have some brain, you can consider this as spark brain, which will pick or do things for you, okay. I mean, plan it accordingly, it will plan it accordingly. I mean, what need to do, what will be the best way to do things. Catalyst looks at your questions and find a quicker path to the answer. It removes unnecessary steps. Suppose in your script you have added few steps which is not required, okay. Choose the better strategies automatically. You write the questions once, Catalyst figure out how to run it efficiently. So suppose you have wrote your script, okay. Catalyst optimization technique will plan accordingly and find out the efficient way to process that. So I'll give you a here a example, okay. So suppose you are planning a trip, okay. Suppose you are in office, now you are planning some trip back to home, okay. So now you are booking a Uber or any other mode of transportation, okay. So when you are in office, you are asking someone or there is someone to suggest you which mode of transportation will be best for you, okay. Suppose you are about to choose Uber, but it is suggesting you Rapido bike will be maybe less cost. I mean, Rapido bike will be cost efficient and it can use the shortcut also, okay. Now it make the plan for you. Now you started the journey. It work is not done then and there. Suppose you somewhere in the road you got stuck, okay. It will again find out a better way. It will reroute if traffic change. Suppose in the middle you got stuck somewhere where there is lots of traffic, or maybe some bridge got broke down, okay. So it will make another plan or reroute your the way to home, okay. And then it will suggest you a better plan. So catalyst optimization here, what I mean to say, it work do not stop while you started only. Even while your job is running, it will keep working and always try to find out and plan a better way to process your data. So catalyst has three superpower. RBO, that we call rule based optimization. So it has some rule, okay, which it utilized while logical planning stage itself. First it come analyzing stage, where it take the data, the statistic of your table, filter, I mean, choose the columns which need to be filtered out, okay. Then rule based optimization, suppose there is some rule, it need to be applied at the starting cell, okay. So it will apply those rules, okay, which will help you to process quicker, and it will make your code cleaner, okay. Then cost based optimization, So when the logical plan and physical plan also ready, then it will choose the it will do the CBO, that is cost based optimization. Choose the plan using data statistic. Okay, so which column to choose, which data to filter out, okay, which data is not required when processing. Suppose you have put join first in your code, then you are doing filter, but it will plan it accordingly. First it will filter out the required data, then it will join, so there will be cost uh, less cost to process that data, particular data. Adaptive query execution, so I just gave you an example in our previous slide, that suppose you got stuck into the road with some blockers, I mean traffic. Suppose it will reroute, I mean it will think again and find out a better way to home for you. Okay, like that. Here we have AQE, that is adaptive query execution. While running, while doing the process, okay, it will always keep thinking how it can be better. Suppose for example, suppose you in your code, it has a plan to join it two data set. So suppose one of that is a small data set, it will but you have not done broadcast join. Okay, but if adaptive query execution is enabled, it will do that for you. I mean, even you have not asked it to do the broadcast join, it will find this as a better way, better plan, and then do that for you. Okay, here I was talking about RBO, quick wins without thinking too hard. Throw away columns you don't need. So in that way, suppose you have 100 columns and you need only 10 columns out of those to process your data and to achieve the actual result you want. So you don't need to read the whole file where you have 100 columns, right? You can use some Parquet file type. You can watch my previous video where I have discussed about the file type and the optimization technique using the file type. So suppose you are using the Parquet file, it can optimize for you, even you when if you have not asked, but it will still choose that 10 column which is required out of those 100 column, and filter out the necessary data. I mean, if you have the whole cell data from 2000 to 2025, but you only require data from 2020 to 2025, it will filter out that for you. Okay, so it will do those things for you. That's called rule based optimization. Okay, it has pre-built rule that to filter out the data which is required. Okay, then CBO, that is cost based optimization, as I mentioned previous slide. Choose using real numbers, so it has the statistic. Okay, catalyst check stat, it already has the statistic, how big are the tables and the columns, how many data are there, how many columns are there. Okay, so based on that, it will plan accordingly, pick the plan with the least work. I mean, less shuffling of the data. Okay, I mean, can you imagine it? Someone, you are just writing the code. Maybe you can make some mistake of the plan while doing the planning, but catalyst optimization itself is there to plan for yourself, even if you are missing something or not noticing something. It will help you to do that. Okay, then AQB, as I just gave you example for broadcast join. Adjust while running. So while running your job itself, it will be active. And if one road is jammed, like I just gave you example. Okay, of the road trip to home from office. Okay, like that. If suppose there is a blocker, there is a data skewness. Okay, it will repartition that. Okay, it was helping you while returning to home, it was helping you by rerouting your way to home. Like if you have data skewness, if you don't know data skewness, you can see my other video for that. But data skewness, suppose it's dividing your data into, suppose you have 100 GB of data, it's dividing your data into five partition, and one partition itself has the highest number of data like 50 GB, and other has like 10 GB, 10 GB, 10 GB, like that. So which has 50 GB of data, that has the data skewness. Okay, and it will split the data. Okay, adaptive query execution, it can split the data inside you. You don't have to be worried about that, and it will create partition and of that data, and it will try to equalize the data into every partition, and it will process the data like that. For broadcast join previous example, if you have missed to do the broadcast join, but you have a small data set and a large data set, it will automatically do that for you. I mean, whenever required, while even while processing, it will do that for you. Okay, so it is able to, I mean, it has the ability to switch strategies. I mean, how it will do the work. It has that ability to switch the strategy midway while processing itself. So yeah, let's move forward. So here I have provided everyday example. Filter at the source, like example, ask the receptionist to only send you the guest you care about. Here is the example of the data, only the data which you need. Like I gave you example little previously. It's like if you have the data for 2000 to 2025, the sales data, but you need only 2020 to 2025 year data. So it, at the starting itself, it will filter out for that. Carry fewer column, bring only the pages you need to the meeting. So instead of I mean, suppose you are going to school, okay, you are carrying all the books you have, but instead of that, it will help you to bring the only those books. I mean, it's right, like timetable or planning of the classes, routine we call it in our childhood. I don't know what it's called now, but yeah, according to that, it will help you to find out only those books, and it will help you to get those books only to the school which is required. In this case, we're talking about columns. As I gave you example, if you have 100 columns, but all that column is not required for processing, to complete the process and get achieve the required result, only 10 column out of those is required. So it will bring only those column to process, not whole table or whole file. Okay, uh, then broadcast small list, like give every assistant the same small contact list instead of passing a big book around. So suppose you have that number, okay, the list of customers which you need to contact, okay, but instead of giving the whole contact list to your employees and ask them to call, you can just give the lead sales lead contact list, which maybe have 10 to 20 lead got generated, and you know that is those are the customer who can buy your product. That was just an example, but in case of data, so it is like you have a small data set and you have large data set. Okay, and it will even if you have forget to broadcast the data using broadcast join, it will do that for you. I mean, it will send this small data set to every executor so that they can use that and do the processing. Okay. Okay, picking a join strategy. So it will pick a join strategy for you. Okay, what will be the best way to join your data? Okay, it's sort merge join, like everyone sort and meets in a big room. So suppose you have two data set which is big, right? It will choose for you the sort must join, because if your data sets are big, both the data sets are big, you cannot do the broadcast join. I mean, that will be the wrong thing to do. But if you have one small, one large, then you can do the broadcast join. So Catalyst decide automatically. Okay, you don't have to do anything. Catalyst itself in its brain will decide everything, that what kind of join it need to do. It is sort merge join or broadcast join. You can also suggest a broadcast, I mean, while writing the code itself, you can mention the broadcast join. But if you are forgetting, and if it think it's required, then it will do it for you. Okay, before and after Catalyst. So how was the world before Catalyst optimal? I mean, when the Spark was 2, version 2. Now it is available from 3, but when it was in the version 2. So before, read all data. It was reading all the data, even if you are using Parquet, but you are not filtering the data, the required column at the beginning itself. Okay, then it was reading the whole data, carry many column, filter it, don't do filter immediately. I mean, if you have a wrote instruction to do the filter, then only it will have filter. I mean, then heavy sorting, this type of process was happening previously. But when we got the catalyst optimization, filter the data at the source itself. I mean, which data is required, carry on needed column only, broadcast small list, fewer faster steps. What you need to do, you don't have to do anything. You just write a clear queries. I mean, clear queries, a code or script. Okay, you don't have to do it. I mean, worried about catalog optimization will do its work. You don't have to do anything for that. Just try to write a clear query or clear script. uh, Follow all the rules you basically follow, like try to try to use the filter first. Okay, you don't have to, even if you are doing it later, but catalyst optimization will take care of that for you. Okay, but as a developer, I'll suggest you should do your part. I mean, writing a script properly is your job, so please go on and do that. So sort data in columnar format, so store data in the columnar format. So yeah, it is your job to store data. If you have watched my previous video about the file structure in Spark, so you must know why I'm saying this, store data in the columnar format. It is easier for catalyst optimization. I mean, if you are saving the data in the CSV format, it will not be able to filter out any data or any column out of your data set or table. Of course, not table. I'm talking about file type. So yeah, if you have a CSV file, it will not be able to filter out columns or data while reading. It have to do, it have to read. I mean, it has to read all the data together. Then while reading in memory, it can filter out the data. But if you are using the Parquet file, it can do it at the source itself. It don't have to read all the data. Particular column which is required, it can read those directly. Okay, if using table, run statistic once in a while. So that is your job. I mean, that thing you have to take care of. So turn on AQE for maximized and skew overload. So here AQE you have to enable. I mean, by default it is enabled until you have disabled it. So you have to check that, and if possible enable it. Okay, that will help your catalyst optimization so to do the job. You just have to enable it. Okay, so yeah, moving forward. So catalyst checklist. So it check what, I mean, the rule based optimization, as I mentioned. Filter early, select only needed column, prefer broadcast when one site is small, avoid black box. I mean, UDF, you know, right? UDF, we create a external function, okay, which we utilize in our Spark job, but that is your catalyst optimization will not be able to plan that. I mean, if you are using UDF, okay, that the reason we try to avoid the UDFs. Okay, collect table statistic, enable AQE. Enable AQE is most important. I mean, it is enabled by default until you have disabled it, but still check check it from your side. So facts, do I need to change my code often? No. Catalysts help automatically, as I mentioned. When should I broadcast? When you have one dataset, small, limited data there, 10 MB, and another you have big dataset, maybe in GBs or TVs, terabytes. So that time you can do the broadcast. And how do I know it worked? So you have the ask Spark to show the plan. I mean, you can comment, provide a comment, explain. Okay, it will explain you how it's worked. So that's it from today. That's it for today, friends. Keep following my videos. I'm getting a lots of love from you guys, and I hope you are liking my video. I'm able to teach you properly. Stay tuned for our next video regarding the optimization. Here we are going to discuss about 30 ways to optimize the Spark job. So bye bye for today.